Imagine you're trying to get something done. Sometimes it feels like you have this super sharp assistant who just gets your goal, figures out the best way there, almost reads your mind.
Yeah, totally.
But other times, it's more like you're giving these incredibly detailed step-by-step instructions. They follow them perfectly, sure, but there's not much independent thought going on.
That's a brilliant way to frame what we're exploring today. It's really about the fundamental differences between two major AI approaches, AI agent systems and the more structured LLM flow-based systems.
Exactly. You hear these terms buzzing around AI circles. And honestly, if you want to quickly understand what's driving the cutting edge, getting this distinction is, well, it's crucial.
Right.
Consider this your shortcut to being properly informed.
And both, AI agents and LLM flows, they both tap into the power of large language models, those sophisticated AI brains that generate human-like text.
Mm-hmm.
But how they use them is really different. And that impacts their capabilities, what they're good for.
All right, let's get right down to it then. What's the core thing, the absolute key difference between them?
The central difference, it really boils down to autonomy. How much independent decision-making is actually involved.
Autonomy. Got it.
Yeah.
So let's start with the LLM flow-based systems. How do they work in terms of control?
Well, think of it like following a really precise recipe. That's pretty much how an LLM flow operates.
Okay.
It sticks to predefined steps, a fixed sequence that the developers lay out beforehand, using things like LangChain chains or structured prompt pipelines.
Right.
The output of one step just feeds directly into the next, like baking a cake from instructions. Very structured, very predictable.
So, like a well-oiled machine follows a set path. Now, what about AI agents? How do they approach things differently?
Okay, now picture maybe a really capable project team. You give them a goal, but not a rigid checklist. They figure out the best way to hit that goal themselves. That's much closer to how an AI agent works.
Yeah.
Systems like AutoGPT or BabyAGI, they put the LLM inside this kind of feedback loop. It learns, it reacts. So this lets the AI dynamically steer its own actions. It can plan, try things out, take actions, maybe using external tools, until it achieves the objective you gave it.
So wait, the agent can actually change its plan as it goes along, based on what it finds.
Precisely. Agents have the authority, you could say, to alter the sequence based on the results they're getting back. And this leads to what we call non-deterministic execution. Because the agent's making choices, the exact path it takes might not be identical every time, even for the same goal.
Interesting.
Like a BabyAGI agent might suddenly realize, hey, I need more info, and decide to create a new little subtask to go find it. All without that specific detour being pre-programmed.
Wow, okay, that is a fundamental difference. So it sounds like flow-based systems prioritize control, predictability.
Exactly.
Whereas agents are like, okay, let's trade some of that control for flexibility, for the ability to adapt and figure things out.
You've got it. That's the core trade-off. Now let's think about how they remember things. Memory.
Yeah, that seems crucial. If you're doing something complex or having a back and forth, remembering what happened earlier feels pretty essential.
For sure. With LLM flows, that memory is generally, pretty limited.
Yep.
It might just cover the immediate context of one interaction, or maybe a specific retrieval step, like in our REES systems.
Right, retrieval augmented generation.
Yeah. If you need the flow to remember more, developers have to explicitly build that in, maybe connect it to a database or something. But often, each new request sort of starts fresh.
It's kind of like having a really short-term memory. It doesn't last long.
In many common setups, yeah. Now, compare that to AI agents. They often have what's called multi-tier memory.
Multi-tier.
Yeah, so you might have short-term memory tracking recent steps, keeping things coherent. But they can also have long-term memory, often using things like vector databases, these very efficient digital libraries that find relevant info based on meaning, not just keywords. This lets them store and recall stuff across different sessions.
So the agent can actually learn and build on its past, its experiences in a way.
Well, in theory, yes. AutoGPT, for instance, keeps a log of recent steps, and you can configure it with long-term memory. BabyAGI uses a vector DB to store task results.
Okay.
But, and this is important, there are practical limits. Even with these memory systems, the agent has to actively decide to access that memory.
Right. It's not automatic.
Exactly. It can still lose track of earlier details if it's not prompted to look back, or if the AI doesn't quite figure out the right query to ask its own memory.
Okay, so memory is powerful, but not like perfect recall even for agents. Let's shift gears. How do these systems interact with the outside world? using tools.
Right. Tools. Both flows and agents can use external tools, APIs, services, you name it, but how they use them is quite different.
How so? What's the flow approach to tools?
In LLM flows, tool use is usually hard-coded. It follows a fixed sequence the developer set up.
Okay.
Like, imagine a chatbot that's always programmed. First, check the weather API, then call the news API. Always in that order, no matter what you asked it. The sequence is baked in.
Right, like pressing specific buttons in a fixed order every single time. And agents, how do they decide which tool to grab?
Agents are different. They dynamically decide which tools to use and when, based on their reasoning at that moment, on the fly.
Oh, okay.
Frameworks like LangChain let developers give the agent a toolbox, basically a list of available tools.
Right.
Then, as the agent runs, the system watches its output. If the agent decides it needs, say, a web search or needs to run some code, it generates a structured request for that tool. The system calls the tool, gets the result, and feeds that information back to the agent. Then the agent carries on.
So the agent is making these real-time calls. Okay, I need this tool right now to get closer to the goal.
Exactly. And it can get even more layered. In some advanced setups, agents can even call other agents.
Whoa. Frameworks like LangChain's LangGraph or Microsoft's CrewAI, they let you build these multi-agent systems where different agents specialize in different things.
Okay.
It offers huge modularity, but it definitely adds complexity in designing and orchestrating how they all work together.
It really does sound like going from that solo chef with a recipe to a whole kitchen brigade coordinating on a complex banquet.
That's a great analogy.
Now, this dynamic nature, this flexibility of agents, it brings up a really crucial question. How reliable are they? Can we actually count on them?
That is a critical point, yeah.
Yeah.
LLM flows, because they're so fixed, are generally more predictable, more reliable.
Makes sense.
The steps are defined, so they're easier to test, and you usually have a clear idea of what output to expect.
Right. So what about agent reliability then?
With AI agents, reliability can be more of a challenge. Because the LLM is interpreting and making decisions at each step, its path can drift.
Yeah, it might make slightly different choices over multiple iterations. You could get different outcomes for the same starting goal. Some folks even argue certain demos of autonomous agents are really just, well, elaborate prompt chains cleverly disguised. And debugging. Debugging agents can be tough. If something goes wrong, figuring out where in that dynamic process it failed isn't always easy. Reproducing the bug can be tricky too.
So it's that trade-off again. Flows give you consistency, dependability. Agents offer autonomy, but you accept a bit more, maybe a lot more, unpredictability.
Precisely. That's the nub of it. Okay, let's think about growth. Scalability.
Right. If you start throwing more tasks at them or bigger data sets, how do they hold up?
For LLM flows, scaling is often, well, primarily an engineering challenge.
Yep.
You might parallelize calls, run multiple instances, maybe shard the data. It's mostly about optimizing performance and managing the cost as the workload increases.
Sort of like adding more identical assembly lines in a factory?
Kind of, yeah. A good way to put it. But scaling agents, especially these multi-agent systems we mentioned, that introduces more architectural complexity.
How so?
You bump into things like context window limits for the LLMs, the runtime costs can escalate quickly with all those agent interactions, and you absolutely need solid ways for these agents to coordinate effectively.
Right.
There are enterprise frameworks like CrewAI emerging that provide better monitoring and orchestration tools to help manage this kind of complexity.
So scaling agents isn't just about more compute power. It's about managing this intricate web of interacting parts.
Okay, let's make this concrete. Real-world use cases. Where does each type really excel?
Okay, LLM flow-based systems are fantastic for tasks where the logic is pretty well defined, pretty straightforward.
Like what?
Things like summarizing documents reliably, Q&A systems based on specific knowledge bases, translation, generating basic code snippets, maybe content creation where the rules are clear.
Customer support bots handling standard FAQs or R-Edge systems for knowledge management. Those are prime examples where flows really shine.
Those all sound like tasks with a clear start, a clear goal, and a relatively direct path. What about agents? Where do they really flex their muscles?
Agents are potentially better suited for those more complex, open-ended tasks, things that might need multiple steps, judgment calls, interaction with various tools.
Examples.
Think about a personal assistant that could actually schedule your meetings across different calendars, maybe do deep automated research pulling from multiple sources.
Okay.
Or even orchestrating parts of a business process like supply chain coordination. There's also a lot of excitement around coding assistants that could potentially write, test, and debug code, though that's still quite experimental.
Right.
It's worth saying, though, that a lot of the really impressive agent demos you see online are often focused on simpler, maybe toy tasks, just to show off the autonomy concept.
Gotcha. So flows for the routine, the structured, agents for the complex, the unpredictable, maybe the future possibilities. What about the actual tech stack? The models, the platforms?
Well, the big players like OpenAI's GPT models or Anthropic's Claude models, they're being used to power both types of systems.
Makes sense.
You see platforms exploring plugins or features that add more agent-like abilities, but often the advice is still to start simple, maybe with workflows, especially for business use cases because of the reliability factor we talked about.
Right.
And then you have frameworks like Hugging Faces transformers, which are great for flows, but they also have an agents framework. And LangChain is obviously a huge toolkit used for building both flows and agents. Lots of options out there.
It definitely sounds like a rapidly evolving space.
Yeah.
Let's talk performance for a sec. Are agents actually better?
That's tricky. Benchmarking this stuff is still really developing. Some studies, like Agent Bench, suggest that things like long-term reasoning, complex decision-making over many steps, and reliably following intricate instructions. Those are still bottlenecks for LLMs when they're acting as agents. Interestingly, for tasks like coding, sometimes a well-designed fixed prompting approach, basically a flow using a powerful LLM, can actually achieve very high pass rates on benchmarks. Agentic coding assistants are often more experimental, maybe exploring novel solutions, but not always as consistently correct on standard tests yet.
So for getting the code right consistently, a flow might still win.
Often, yes, currently. And for things like information retrieval, Argue, which is fundamentally a flow, still excels. So the takeaway seems to be, for tasks that are primarily about leveraging the LLM's core capabilities, text generation, summarization, basic Q&A, flows are often better, or at least more efficient. For interactive, multi-step tasks requiring planning and tool use, that's where agents could theoretically shine. But current benchmarks suggest they don't always surpass well-designed flows yet, especially on simpler tasks. They might get close on complex ones under ideal conditions.
That's a really important nuance. So finally, let's talk deployment. What are the big hurdles people face when trying to actually put these systems to work?
Okay, for agents, there are definitely a few key challenges. Debugging and monitoring that dynamic behavior is complex, as we said.
Right.
They generally need more compute resources, which means higher costs, partly because they might make many calls to the LLM. Security is a big one, especially if you let them use tools that interact with the real world or internal systems. You need robust data and memory infrastructure if they need to learn over time. And their unpredictable response times can be, well, frustrating for user experience.
That's quite a list. What about the challenges for the simpler flow-based systems?
With flows, the main limitation is that rigidity. If the problem changes, even slightly, you might have to go back and rewrite significant parts of the flow. They don't adapt at runtime beyond the logic you explicitly coded, and they lack that inherent long-term memory or dynamic decision-making capability that agents promise.
Okay, so wrapping this up, it sounds like LLM flows are reliable workhorses, right? Like those dependable recipes. Great for structured tasks, very consistent.
Exactly. Predictable, efficient for the right job.
And AI agents are more like those creative, adaptable chefs. They can tackle complex, open-ended challenges in flexible ways.
Huge potential there.
But they come with caveats around predictability, reliability, and needing more careful management.
Absolutely. You need to be aware of the trade-off.
So the choice really seems to hinge on what you need for a specific task. Predictability, efficiency for routine stuff. Maybe you lean towards a flow.
Probably a good starting point.
But for those really messy, complex, evolving problems, maybe an agent's autonomy is worth exploring just carefully.
Precisely. Weigh the pros and cons for your specific situation.
It definitely leaves you thinking. As AI keeps evolving at this incredible pace, how might this balance this tension between structured predictability and autonomous flexibility? How might that reshape the tools we use every day, and maybe even the kinds of tasks we decide to delegate in the first place?
That's a fantastic question to ponder. It's certainly going to be fascinating to watch unfold.